When the wind sweeps across the open plains of Pleistocene North America, it carries whispers of creatures that once towered above the modern world. Imagine a beast the size of a small house, its massive limbs crushing the earth with each step, its presence reshaping rivers and forests alike. These were the giants, Megafauna, whose reign spanned millennia, only to vanish in a sudden, silent collapse that still puzzles scientists today. The story begins with the woolly mammoth, a shaggy colossus that roamed the tundra from Siberia to the northern reaches of Canada. Standing up to 14 feet tall at the shoulder and weighing as much as a modern African elephant, its curved tusks could reach 6 feet, perfect tools for foraging through snow and ice. Their herds followed the rhythm of the ice ages, their migrations marking the pulse of a changing climate. Across the Atlantic, a different titan stalked the forests of Europe, the straight-tusked elephant, Elephas antiquus. Unlike its woolly cousin, it favored temperate woodlands, its massive body adapted for a diet of bark, leaves, and fruit. Fossil evidence shows individuals exceeding 15 feet in height, their massive skulls supporting elongated, almost vertical tusks that could pierce the toughest of trees, reshaping the very canopy they fed upon. But the giants were not limited to proboscideans. In the grasslands of South America, the giant ground sloth, Megatherium, rose to the size of a small car. Its claws, spanning a foot across, were capable of pulling down entire trunks, while its massive, barrel-shaped body could reach a height of 20 feet when standing upright. This slow-moving herbivore played a crucial role in seed dispersal and forest regeneration. Further north, the saber-toothed cat, Smilodon fatalis, prowled the night with jaws that could crush bone. Though not as massive as the woolly mammoth, its muscular frame and forelimbs were built for ambush. The iconic elongated canines, some exceeding 7 inches, made it a feared predator, capable of delivering a killing bite to the throat of a bison or even a young mammoth. In the deserts of Africa, the now extinct African megafaunal titan, the giant hippo, Hippopotamus gorgops, once dwelled. Its skull alone could rival a modern adult male hippo, but its body stretched over 12 feet in length, with a massive jaw that could snap a small tree trunk. This semi-aquatic behemoth altered river courses, creating wetlands that nurtured countless other species. Across the Pacific, the island of New Zealand hosted the massive Moa, a flightless bird that reached heights of 12 feet. Lacking any natural predators, moas filled the ecological niche of large herbivores, browsing on ferns and shrubs. Their extinction, driven by human hunting just a few centuries ago, serves as a stark reminder that the loss of giants can be abrupt and recent. The disappearance of these titans did not occur in isolation. Around 12,000 years ago, a cascade of extinctions swept across continents, wiping out up to 80% of large mammal species. Climate change, habitat fragmentation, and the arrival of Homo sapiens converged, creating a perfect storm that erased an era of colossal life. One prevailing hypothesis points to rapid warming at the end of the last ice age. As glaciers retreated, ecosystems transformed faster than many species could adapt. The once abundant grasslands gave way to shrublands and forests, altering food sources and forcing megafauna into shrinking refuges where competition and disease thrived. Equally compelling is the role of early humans. Archaeological sites reveal butchered bones, stone tools, and fire pits associated with mammoth and mastodon remains. The efficiency of coordinated hunting, coupled with the spread of fire to reshape habitats, likely tipped the balance against species already stressed by environmental change. The loss of these giants triggered cascading effects throughout ancient ecosystems. Without megaherbivores to graze, vegetation overgrew, altering fire regimes and reducing open habitats for smaller mammals. The disappearance of top predators like Smilodon allowed mesopredators to proliferate, reshaping the food web in ways still detectable in modern ecological studies. Yet, remnants of their legacy endure. Fossilized dung, known as coprolites, provides insight into diet, migration patterns, and even the microbiomes of these extinct giants. DNA extracted from well-preserved remains has opened a window into their genetic makeup, allowing scientists to reconstruct evolutionary relationships and, in some cases, contemplate the extinction projects. Modern conservationists draw lessons from these ancient losses. The rapid decline of today's elephant, rhinoceros, and large carnivores mirrors the pressures faced by their prehistoric cousins. Understanding the complex interplay of climate, human expansion, and ecological balance is essential to preventing another wave of silent disappearances. As we stand amidst a planet still bearing the scars of those forgotten giants, the question remains, can humanity learn from the past to safeguard the future? The bones beneath our feet whisper a cautionary tale, a reminder that the dominance of size is fleeting, and that stewardship of the earth must transcend the allure of progress alone. From the towering ferns of the Devonian to the colossal ammonites that spiraled through ancient seas, we find a pattern. Ecosystems once ruled by giants collapsed under their own weight, their remnants fossilized as warnings. The sheer scale of these organisms reshaped coastlines, altered climate cycles, and even redirected river systems, leaving an indelible mark on the planet's geological record. Consider the megafaunal extinction at the end of the Pleistocene, when woolly mammoths and giant ground sloths vanished almost overnight. Their loss reverberated through trophic chains, allowing smaller herbivores to flourish, but also disrupting seed dispersal patterns that had persisted for millennia. The disappearance of these titans created a vacuum that early humans swiftly filled. By hunting the remaining large prey, our ancestors honed tools, social structures, and cooperative strategies that would eventually give rise to civilization itself. Yet the same drive that propelled humanity forward also sowed the seeds of its modern challenges. The domestication of animals, once a survival necessity, now contributes to greenhouse gas emissions that echo the ancient climate shifts triggered by extinct giants. In the oceans, the ancient Leviathans, such as the giant marine reptiles of the Triassic, left behind massive bite marks on the fossilized shells of their prey. These scars reveal a world where size dictated supremacy, but also where evolutionary arms races spurred rapid innovation. When the seas cooled and nutrient flows shifted, those marine giants dwindled, paving the way for smaller, more adaptable fish to dominate. This turnover reshaped the marine food web, influencing everything from plankton blooms to the migration patterns of early whales. On land, the rise of the first towering conifers created new habitats for insects and birds, which in turn pollinated and dispersed seeds across continents. The interdependence of these organisms illustrates how the loss of one giant can ripple through countless smaller lives. Fast forward to the age of dinosaurs, where the sheer magnitude of sauropods like Argentinosaurus reshaped entire ecosystems. Their massive footprints compressed soil, creating microhabitats that fostered unique plant communities, some of which persisted long after the dinosaurs' demise. The sudden asteroid impact that ended the Cretaceous period erased those giants, yet the ash cloud it generated fertilized the soil, enabling the rise of flowering plants and, eventually, mammals. In this paradox, destruction birthed renewal, underscoring the cyclical nature of planetary change. Modern scientists now use these ancient narratives to model future scenarios. By simulating the collapse of today's megafauna, such as elephants and whales, we can anticipate cascading effects on carbon sequestration, biodiversity, and human economies. In the Arctic, the retreat of massive ice sheets mirrors the ancient glacial retreats that once exposed new land for colonization. The newly uncovered tundra is already being reshaped by pioneering plant species, much like the early colonizers of post-glacial Europe. Ultimately, the story of Earth's lost titans is not merely a chronicle of extinction, but a lesson in humility. As we stand upon the shoulders of creatures that once dwarfed us, we must remember that stewardship is not a privilege of the present, but a responsibility inherited from the very bones beneath our feet.